Hello, everyone. So I think we're just going to wait a minute or two and let other folks join in, and then we'll kick this off momentarily. Okay. For those of you who are already logged in, you'll notice the chat. Maybe a few of you can just confirm that you can hear me and send a note that we can confirm and before we move ahead. Excellent. So it looks like the audio is working well. I presume you can all see my screen with the, with the title of our infrastructure as code in OpenNebula using Terraform. So I'm going to kick this off. I think we're ready to go. Okay. So we are very excited today to be hosting today's webinar as part of our OpenNebula webinar series. This is a series that we've been carrying out throughout this year and which we'll continue to promote with the idea of bringing interesting virtual events to the community. And at least for the remainder of 2020, our focus is going to be on coordinating and participating primarily in virtual events. So we hope that you can keep a close eye on the developing events calendar and that you'll join us whenever you can. So here's a quick introduction to those involved in today's events. That's me, Michael Abdu. I'm the Customer Success Manager at OpenNebula. And today I'm joined by Taylor Dolezal, who is a Senior Developer Advocate from HashiCorp, along with Jean-Philippe Forez, who's a Cloud Product Manager from Iguana Solutions. And we're pleased to have both of them joining us today for what we think is going to be an interesting and worthwhile event. Okay, so here's a short introduction, a brief introduction of the agenda for today. I'm going to start off just providing a short introduction to OpenNebula. We're going to take a quick break in between there and a quick intermission to do a quick poll. And then after that, Taylor is going to provide an overview of infrastructure as code utilizing Terraform. And then Jean-Philippe is going to finish up providing an overview of the Terraform provider for OpenNebula and running through a quick demo as well. And then at the end of Jean-Philippe's presentation, we're going to jump into a Q&A session. We will be asking all of you, for any of you who have questions to post, to use the chat, and if you can, try to send your questions through the chat towards the end of the presentation, and then what we'll do is we'll go through those questions and answer them accordingly. Okay, so I'm going to jump into that short introduction to OpenNebula. So what is OpenNebula? It is essentially an open source virtual data center and cloud management platform. We like to call it the operating system of the cloud. With virtualization technologies like VMware, KVM, LXD system containers, and most recently with Firecracker micro VMs in our latest release, you can develop and easily manage your own multi-tenant cloud environment. And with shared networking and storage resources, OpenNebula provides a simple and flexible platform for you to build an enterprise cloud. It comes with a built-in user interface called Sunstone, and it easily integrates with third-party tools for development like Terraform, which we're going to be reviewing today in detail, along with other tools like Kubernetes, Ansible, and Docker. So how is OpenNebula being used? Here we like to say OpenNebula provides one cloud to rule them all, right? And it's a sly reference to the Lord of the Rings, but it's also a keen reference to the fact that while OpenNebula takes its roots from the private cloud, it has evolved by providing all the benefits of a managed private cloud, while at the same time, right, easily being able to integrate not only on-premises resources, but also hosted resources, edge resources that can be provided by public bare metal resource providers, as well as with public cloud providers like Amazon and Microsoft Azure for cloud bursting to create hybrid clouds. And this is what we're calling the enterprise cloud. Okay. So this is simply a quick look at our Sunstone user interface, which is really a simple, straightforward platform from which both admins as well as end users can manage their cloud resources. Okay, and here, a little bit of history around OpenNebula highlights the fact that it's an open source solution that's driven by a genuine open source project. Okay, so we have over 10 years of experience developing and bringing infrastructure solutions to market. And OpenNebula has developed over this period of time with a huge influence by our community of users. There are over 5,000 OpenNebula clouds currently running, the largest of them spanning 16 different data centers and 300,000 different cores. And if you take a look below, you'll see some of the users and customers of OpenNebula spanning all industries. Among other things, this really just helps to highlight not only its broad flexibility, but also the fact that it's production and enterprise ready. Okay. And here I'm just going to take a quick moment to review our OpenNebula subscription. It's the subscription that we offer is really the key to being able to get the most of your OpenNebula solution. Okay, so with a subscription, you get SLA-based support, which is provided through a private portal, right, and granting direct access to our support team for quick resolution to production issues or to address day-to-day questions that you may have. It also provides access to the Enterprise Edition and Enterprise tools. The Enterprise Edition is a more tested and hardened version of the software, which is ideal for implementations in production. And the subscription also, like I said, provides access to enterprise tools like OneScape, which has been built to simplify and automate the upgrade process. And going forward, it's going to become a power control panel for simple management and maintenance of your OpenNebula solution. Subscribers also get access to our curated knowledge base with best practices and step-by-step guides and use case overviews, which are really all designed to feed you with insight to keep you current and things running efficiently. And subscribers also have access to our professional services, right? They're offered by our OpenNebula systems team, which includes cloud deployment services, upgrades, training, and consulting and engineering services, among others. Okay, so where do you start? We have several tools that are built to allow you to very quickly deploy and begin evaluating OpenNebula. Our V1 Cloud appliance is something you can download here at the V1 Cloud OpenNebula.io. This is for users who are running VMware infrastructure, and you want to essentially create an OpenNebula, a multi-tenant cloud right on top of vCenter. We also have Mini One, which essentially allows for a simple deployment of a single node cloud if you're running on top of LXD, KVM, or Firecracker. And then the last link here, really just there to allow you to take a look at what we've introduced in our latest release of OpenNebula 5.12 Firework. You should go take a look at some of the latest capabilities. Hopefully you get a chance to download it if you haven't done so already, and get out there and kick the tires. Okay, so here's that quick intermission. Like I said, we're gonna take a few minutes to kick off a poll. Hopefully you can answer these 1 or 2 questions, and then we'll get back right to the webinar. Okay, so we've closed the poll. Or you can take a look at the results. Interesting. Great. Okay. So now I'm gonna hand things over to Taylor, and he's gonna walk us through infrastructure as code with Terraform. I'm gonna stop sharing. There we go.
Howdy, everybody. I am going to start sharing my screen here. All right. All right. Does everybody see my screen? Awesome. Okay. So hi, everyone. My name is Taylor Dolezal. I work for HashiCorp. You can find me online as @onlydole, ONLYDOLE. Today, I'm going to be talking to you about understanding infrastructure as code with Terraform. So again, thank you so much for coming. Hope you're doing wonderful for a Monday. So let's take a look at what we're going to be covering today. First, we're going to dive into infrastructure as code and explain what it is. Note that this is not just knowledge that will help you understand this webinar and the content inside this webinar, but it has long-term benefits as well. Then I'm going to cover a typical workflow pattern using Terraform. And then finally, we're going to be talking about some more advanced use cases and learning resources. Some of the things that we'll talk about in that section are also meant for you to use when you want to take Terraform a little bit further. So let's start talking about infrastructure as code. When we refer to infrastructure, we mean that in the information technology sense. That means machines, applications running on those machines, and any associated resources such as databases or firewalls. The formal definition of infrastructure as code, or IAC, as it is referred to, is the process of managing and provisioning resources with machine-readable definition files, as opposed to manually configuring resources in a user interface. So instead of pointing and clicking, having a declarative definition of how you want things to be set up is really what that's saying. Think of Terraform as executable documentation. Terraform is the HCL that you use to create it. It's human readable, but you're also able to run it as you iterate on your infrastructure. Terraform provides you the ability to create infrastructure-defined files that you can commit to Git. And since it's in your code, that gives you the ability to roll back, roll forward, try out a new feature, and pull things down accordingly, which is really nice. That allows you to be a little bit more safe and predictable rather than, if you delete a file on a live server, the consequences it's fun, it's risky, but definitely don't recommend that in production. As you can imagine, infrastructure as code is quite useful. Understanding the overall workflow is important because it allows you to try new things and still be able to return to a state that is in known working configuration. So that's infrastructure as code in a nutshell. How do we write that? What language is it in? When you write code for Terraform, you do that using a language called HCL, which stands for HashiCorp Configuration Language. This is a common language that is supported by all of our tools, like Vault and Consul and Nomad. Let's have a look at what HCL looks like, though. So let's pop open our code editor. So in this example, we have a resource called service. This resource has a single key value item. I'm keeping this simple for now, but the service item could have many more key values that define additional attributes. Let me show you a little bit more involved example with a named service. So we will use the HTTP service and name the resource web proxy. And then we can add a key value to define the listen address. This one's a localhost at 8080. Then we will add another object to define the process that we're proxying. Then we'll provide a command that gets run with an argument. In our case, that application is called proxy app. Convenient. HCL is both human readable and machine readable. It's JSON compatible and supported by all major code editors and IDEs. Typically, this syntax can be understood after using it for a few hours, which is quite helpful. Now, let's say you're writing a lot of this code and you don't want to keep having to repeat values over and over again. Something like a variable. More importantly, you don't want to have to hard code everything. So how do we do that? For those cases, we can use variable syntax. So let's go ahead and define a new variable. We'll call this one port. Let's give this a default value of 8080, same as we did for the service above. HCL supports descriptions so that you don't always need to remember what the purpose is of every variable. Here we did make it quite easy. We named things server and port. Those hopefully that's not too confusing. But if there is a variable that we're using that's a little bit harder to remember, or we want to provide more context, description is best practice for sure. They say two hardest things in programming are cache invalidation and naming things, and they're right. That's where description comes in to save the day. So next, let's update the web proxy resource and change the listen address from this hard-coded value to the dynamic one that we just created. We'll do this by adding a little bit of code, put that var.port in there, and wonderful. Now this value is something that is dynamic, and we can change that whenever the port is to change. All right, so congratulations, everyone. We just made it through our first foray into infrastructure as code. So now that we have an understanding of infrastructure as code, let's talk a little bit more about Terraform. Terraform is a platform that supports a wide range of external services. Terraform uses what are called providers. Each provider is responsible for understanding API interactions of a specific service and makes it available to you. So some quick stats for you. HashiCorp maintains around 125 official providers. These range from Amazon Web Services, Google Cloud Platform, OpenNebula, Docker, Kubernetes, and many, many more. Then there are roughly 175 community maintained providers for services such as Auth0, Sentry, and even Domino's Pizza. Now, who doesn't love pizza? So let's get started with Terraform. In these first steps, we're going to walk through some of the most commonly used Terraform commands and when you would use them. So let's pop open our terminal and get started. In this talk, we won't actually be standing up infrastructure. We're just going to make an assumption that we have some Terraform code already defined. We have some providers, our Amazon configurations all done, and we're in a good state to get started. If you have any questions about how to actually do that, by all means, please feel free to reach out to me. I'll share my details after this talk. So to get started with Terraform, you're going to want to run the Terraform init command in your terminal. Think of Terraform init as git init. Similar to git, it will create a .terraform folder within your file path and start to download those providers that you have defined. Terraform init is a helper command that sets up your local directory with all of the right binaries for anything that you have configured or providers that you have defined. So in this example, we can see we're using AWS. Everything looks good. Now let's take a look at Terraform plan. Terraform will render our resource graph, and we'll want to output a plan file. Reason that we can run Terraform plan without this -out flag, but usually it's better to define that such that we know what we're planning is actually what is going to then later be applied, which we'll get into shortly. So here, when we run this command, Terraform will show you all of the changes that it's about to make, and then we're saving it into that aws.tfplan file. Our plan looks good, so let's apply this. This step might take a little bit of time because Terraform is communicating with your cloud API. So depending on how that's set up and your latency is, time will vary. So in this plan, in this apply, we are instructing, we have some Terraform code that's going to be spinning up a EC2 machine. Oh, and we're done. Our instance is created. So let's talk a little bit about Terraform output. Sometimes you might need to output a value like a DNS zone or a load balancer address. This can be really helpful when you start using Terraform modules, which is a little bit beyond the scope of this talk, but quite useful, quite helpful. How might we go about seeing and using outputs from our infrastructure as code? Conveniently for us, you can use Terraform output for that. So if you just run Terraform output, that will print out all of the outputs that you have defined after you've completed a Terraform apply run at least once. If you want to see a specific output value, you need to be a little bit more specific with Terraform and supply the output's name. And there it is. So we have our volume device name with Terraform output. So say that you do a lot of experimenting, you've spun up a lot of resources, you're going to not want to keep paying for that infrastructure, right? Especially if you're testing things out. So let's talk about how we can terminate those resources and not spend a lot of money. Terraform has a command called destroy, which will destroy any infrastructure that it manages that you've spun up. Now, this is useful because cloud resources cost real money, and at the end of the day, you don't want to be wasting any of your hard-earned money. Just like apply, we want to first see what we're about to remove. So let's use Terraform plan again, but instead let's add a dash destroy to the end. This will generate an execution plan of resources that will be removed. As before, we can apply this execution plan by running Terraform apply and appending that .tfplan file. So it might take a few seconds or minutes while Terraform removes all of our resources. And oh, there we go. 3 resources have been destroyed, and we are no longer paying for them, which is fantastic. As you type out your Terraform code, you might not have your spaces and indentations set correctly. So before we go about, as we're writing our code, say we want to format things, we have another command that is really helpful, and that's the Terraform fmt or format or fmt command. This will clean up your code and format it according to best practices, which makes it really easy, letting the machine do the hard work for you and format things. So in this main .tf file, we can just run Terraform format, and we're good to go. Looks like everything was defined just fine. Terraform validate is another helpful command. It checks things without looking up any APIs or pulling in any values, and make sure that your syntaxes are right and you have well-formed code. My recommendation is to use Terraform validate often. Same with format, just to make sure that everything looks good. And then, of course, Terraform has a large number of command line interface commands, and you won't use all of them all the time. But if you're ever stuck, you can use Terraform help to find out a little bit more about a specific command and what it does. All right, so now that we've covered the basics in Terraform, let's talk a little bit about the Terraform lifecycle and Terraform state. So while we were working in terminal view, you might have noticed that we followed a specific flow, and that was the Terraform lifecycle. We started with Terraform init to set up our project and to get our providers. Then we wrote some code, made sure it was nice and cleanly formatted using Terraform format. Then we followed that up with Terraform validate to make sure that our syntax was looking good and we had defined all of our variables and names correctly. Then we generated an execution plan using Terraform plan. And then we saved this execution plan to a .tfplan file. That execution plan looked good, so we applied it using Terraform apply. And then after we were done experimenting and working with our files, we created a destroy plan by adding -destroy to the Terraform plan command. And that's what a basic Terraform lifecycle looks like. Let's talk a little bit about Terraform state. Terraform state, we have a Terraform state file, and that keeps track of our resource metadata. So any of our provider identifiers, image tags, machines, volume, mounts, and more. The state file also helps to keep Terraform performant, especially when you have large scale infrastructure. By default, your state, your Terraform state is stored locally in a file called terraform.tfstate. A local state approach, I mean, just kind of the way it works out of the box, might be fine if you're testing or getting started with a new provider, but I strongly recommend on storing it remotely, which is defined in the Terraform documentation. As there's some horror stories around people that have lost their state. It's just not a fun state to be in, quite honest with you. All right, so that pretty much covers all that I have for you today. So let's review what we had covered. We started out by explaining a little bit about expressing your infrastructure resources as code. Then we introduced you to Terraform and how it fits into an infrastructure as code world. Then we talked about Terraform lifecycle and state. And if you want to have another look at slides today or whenever, feel free to check out this link. I'll share this out. On learn.hashicorp.com, there are also several useful guides on how to use Terraform and our other tools. If you use this link that I'm showing right now, you'll be taken directly to the Terraform section. I also have a QR code for you too. If you don't want to have to manage your state like we talked about, or set up a CI/CD workflow, Terraform Cloud can help with that. Again, feel free to scan this code and see if it might be a solution that works for you, your team, or a weekend project. There is a free tier that you can get started with, and it's useful. I just started using this recently and have been a big fan so far. So thank you very much. Again, my name is Taylor Dolezal. It has been an absolute pleasure to talk with you today. And if you have any questions for me, please drop them in the chat and we'll answer them in the next section. Thank you very much, everyone.
Awesome. Taylor, thank you so much. That was a great overview. All right. I'm going to quickly just share my screen as we prepare to have Jean-Philippe. He's going to jump in and
yes,
Jean-Philippe,
sure.
you can share your screen here. I just wanted to put the intro slide, but I'm going to stop it and let you take over.
Yeah, sure. I'm sharing my screen. Okay, so before the live demo, I will just talk about who we are at Iguen Solution and how the Terraform integrates with an OpenNebula environment. So Iguen Solution, we are a service provider providing service around infrastructure. We exist since 20 years now, and we are based in France, in Paris, and we have facilities around the world. We are infrastructure experts, specialists of the cloud hybridization. Cloud hybridization means for us also private and public cloud, and also infrastructure, dedicated infrastructure, and virtualization. We have a DevOps culture, and all our internal tools are based on open source. So that's why we choose OpenNebula to manage our virtualization infrastructure. So now, okay, we have OpenNebula, but managing VMs on OpenNebula is very nice thanks to the CLI and the Sunstone UI. But we need to integrate and to manage them with infrastructure as code tools, such as Terraform, which is one of the best known and usually used tool to manage infrastructure. Thanks to Taylor, you had a very good view of what Terraform can do and what is infrastructure as code too. So here is a small story of the provider. We started to develop it in October 2018, and based on the Golang API provided by OpenNebula. To develop this beta release, we need to contribute a lot to the Goka, which is the short name of the OpenNebula API bindings. So we did a lot inside it, and then we could write a good first version of the provider. This first version of the provider was added as an OpenNebula add-on in June last year. And after the summer, we submitted it to HashiCorp for review. And in November last year, it was official in Terraform. Since then, with some first draft of resources, such as the group, image, security group, VDC, virtual network, VM, and VM template. Since then, we fixed some issues, we added new features, and we also added new resources, such as VM groups and ACLs. Thanks to an external contribution, ACLs. For more details about what is exactly in open as issues and maybe in roadmap, you can go directly to the GitHub repository. And you also have the link to the official documentation. It's already reachable from the docs as an official provider. You already have the documentation of the provider on the Terraform website. That's for the history and how you can use it. So thanks to Taylor, you just have to write to an HCL file, or maybe several ones if you want to split for readability. So on the left, you can see the Terraform file. It's the input of the provider, and then you run the Terraform init if you don't have already did it. Then Terraform plan. It should display what you are going to do, and then you apply it. And thanks to HTTPS queries to the OpenNebula endpoint, it will then deploy what you write in the Terraform file. So it will create VNet if you need to create a VNet. It will create data store images to be used as the disk image for each instance. And then, of course, it will deploy instance. Once it's done, Terraform, the provider, will write the dev state file with the entire status of the infrastructure. And then it will be very useful for future use when you perform changes in your infrastructure. That's for the typical workflow. To go deeper, as you see here, the Goka on the top of the slide, it's because it's integrated in the Terraform provider as a library. And from the Goka, Terraform uses a lot of files. It uses every package, sub-package describing each OpenNebula resources, such as ACL, group, image, security group, template, EDC, virtual network, VM, and VM group, and also some shared files. So, as I said, last year, it was the first version of the provider, the 0.1. Since then, at the beginning of the month, a new release was performed. This new release includes new features, new resources such as ACLs and VM group. So now you can manage user rights via Terraform, and also you can create a group of VMs. It's very useful to manage affinity on your cluster. And also we added some interesting features. So thanks to the VM group resources, you can now associate a VM to a VM group to manage affinity during the deployment. We added tags feature. If you want to tag your infrastructure, it's totally customizable thanks to the key value support of Terraform. So it adds keys and values to your resources. And also, because it can take some time to deploy VMs or images, if you upload an ISO file, for example, to your OpenNebula cluster, it can take a long time to be uploaded. So we added a timeout configurable parameter for VM and image. And other major changes, we did lots of improvement of VM and VM template to use a common structure between them, because a VM template, it's a kind of VM. And when you create a VM, you can instantiate a previously created template. So they share a lot between them. So it was interesting. It's interesting to use the same structure. And also, thanks to OpenNebula context, we decided to do something better between VM and template during the merge of the context part. As we can create a VM template by describing several elements of a VM, I mean a CPU, RAM, disk, and so on. The parameter template, which was for reading a file containing the entire template, was deprecated, is now deprecated. And also we do some bug fixes, such as the documentation. It was very buggy at the first draft. Now we fixed some stuff, or maybe there are still some mistakes, but it's now better. So feel free to read it and to raise issues if you see some issues on the provider, of course. So now how to use it. So it's relatively basic. There are not a lot of parameters as the input. I mean, you just have to describe, to create a few variables to reach the endpoint. With the endpoint URL, the username you want to use to reach the platform, and the password, or the token. If you don't want to use a full password, you can create a specific user and a token with an expiry date. Then you just have to initiate your provider with these values, and then you can directly use data source and resource. For the example here, it's just to clone an existing image to create a new one. And of course, you can also create another TF file to see the output if you want to get output values, for example. So now I will just go to a very basic demo using a Mini1 instance. It's very useful, Mini1, for this. So thank you, OpenNebula, for sharing this tool. So the demo will consist to deploy a very basic infrastructure, and also one other interesting tool from Terraform is the import command, because some of you maybe have already an OpenNebula cluster already deployed, and the idea is to not reinvent the wheel. And if you want to use Terraform to manage already deployed instances, you can do it thanks to import. You need to import resources into Terraform, and then you can manage now your previously deployed resources. So I will stop sharing this screen and I will share another one. So yes, you are seeing my Terraform file. I will zoom a little bit. I hope you can see the file. So it's very basic. just 3 variables. Then the provider, I forced the version to the last one. Here there is just a data source VNet, but I don't use it actually. And here I will create an image resources, and I will create a VM group with the policy assigned, with the tags demo, and I will create 2 virtual machines. I don't use the count feature here, but it's also possible to use the count feature too. So let's see.
Jean-Philippe,
Yeah.
do me a favor and take off the panelist window from the screen for the Zoom. Do you see the small white? No? Now we can no longer see your screen.
Yeah, I know, but I can't.
Okay.
I can't.
Okay.
Yes, I will do it. Okay. Let's see. Is it better?
Good. Thank you.
So now here is the plan. So you can see I will create 4 resources, which is 1 image, 1 virtual machine test, 1 virtual machine test 2, and a virtual machine group. I will do it. And I will apply it. So it takes some seconds. Okay, so now the resources are created. We can go to the Sandstone view. I will share another screen, sorry, up here. So here you can see the 2 virtual machines. You can also see here the test image just created just thanks to Terraform, and the VM group here with the 2 created VMs from Terraform. That's very simple. And if I go to the terminal again, that if I want to, you can now, it's okay. So now we can delete it. We can destroy. What I wanted to do is to import a resource. So I will edit my file. As you can see, I will just uncomment the import VNet resource, and I will use the import command just to import the VNet into Terraform. So now I imported it previously created VNet on OpenNebula. And if you edit the gfstate file, import, here is the VNet imported. That's what I did. And if I just want to destroy what I created just before, because now I have 5 resources instead of 4, I will just destroy what I created. Oh, sorry. I missed something in the presentation from Taylor. Okay, I will do it. One other interesting stuff is to use the target. You can delete specifically resources instead of destroying the entire infrastructure. Here, I will just destroy the image I created before. Okay, so now it's destroyed, and if I go to the image in the storage and I share my screen here, okay, as you can see, there is no the test image. There is only the CentOS 7 image by default with mini1. So it's very simple. That's for the first version of the demo. I didn't want to go too deeper into Terraform just for this introduction. So if you have questions or so on, that's open.
No, that's great, Jean-Philippe. That's a great demo. I think what we'll do now is we'll open up the Q&A session. Okay, so for those of you who have questions you'd like to pose, please use the chat and send them along, and then and we'll take a look at the questions that are coming in and answer them. We'll have, you know, it's technically a few more minutes here, but we'll get through some questions here. Okay. Let's take a look. I'm going to stop sharing for a sec.
I can see a question from Raphael about the service creation. Yes, it is in roadmap. I don't have an ETA yet, and it's something we are working with the OpenNebula team. Christian from OpenNebula already did a PR, and I just wanted to wait for the release 0.2 to be out before merging it, because it's a new resources introduced by the 5.12 release, and the next Terraform release will be compatible more with this version.
Excellent. Okay. So just regarding the webinar itself, webinar in you know, actually Taylor provided his slides already. They're out there on he provided a link, and with regard to the webinar itself, we'll be posting a recording within a few days' time. So keep an eye out from on our website if you want to come back and take a look at the recording of the webinar. Let's see, we have another question.
I do see it.
Yeah. There is another question From Alexander?
I did. Yeah, so I saw that. So Alexander asks, if I lose track of my state in Terraform, like something went wrong with the deployed resources, is it possible to recreate the link between Terraform and my infrastructure? Feels like this is somewhat dangerous to have this kind of static relationship between state and infrastructure. So great question. When it comes to, so we have to have state no matter what when it comes to infrastructure, whether that, you know, obviously what is running is you know, ideally what you should have in your Terraform state file. The machines that you have running is a state, you know, so to speak. So we do have to track state somewhere. We do want to make sure that that state is protected. And when it's set up locally, that can be safe, but you are absolutely right. You run the risk of accidentally deleting the file, something happening to that machine, you know, the unknown. And the best way to store your state file, my recommendation, you know, if you're using a cloud like AWS, you can store that in S3. And there's some documentation and ways to do that in the Learn links that are in the at the end of the slides that I provided. Definitely recommend checking that out. Otherwise, you can use services like Terraform Cloud, Enterprise, and other solutions that exist to help you store that state and keep that safe. If you have any more questions on that front, I'm more than happy to answer them directly too, because I know we're limited on time. But yeah, feel free to ask me anything more on that. I'd be more than happy to provide some more info.
Yes, and to complete Taylor's answer, you can also store it in a Git repository, just to not lose it. And the best to do is to deploy a CI to manage this kind of stuff. Because if several people are involved in the infrastructure management, if everyone run Terraform locally on his computer, it can be a nightmare to manage. So it's important to have a CI/CD to manage this, so as other development tools. And I see another question from Lorenzo. What about modifying templates and or object attributes? Actually, Lorenzo, it depends. It depends of the attribute you modify. If you change on the OpenNebula provider, if you change some attributes, it won't recreate everything. Some of them will force to recreate the resource. I mean, if you create a VM by instampating a template with its ID, if you change the ID of the template for this VM, it will recreate the VM. It will destroy it and recreate it. Of course, if you change the name of an attribute, it will rename it and so on. But for example, if you create a VM with a nick, and if you add another nick after, it won't attach it for the moment. We didn't implement this feature for the moment. It will come, but not yet.
And one quick thing I wanted to clarify on that state question too. If you do store your state within Git, I definitely recommend adding the .terraform git ignore to those files, just because the way that Terraform stores state, if you spin up a database or you provide sensitive credentials for things like that, like a RDS instance, for example, and you're not using Vault or a secret store, if you're not looking it up with like, say, you know, data call out, those values will be in plain text in that Terraform state. So if that's the case, obviously you won't want to store that within your Git history. So just to keep you safe and keep your values safe, definitely recommend putting that in S3 or trying to get that set up remotely. You can stub the Terraform state out and give that directive within your Terraform code. And then that's going to be the best way to share if you've, you know, 2 or more teammates that you're working with as well.
Okay. And Taylor and Jean-Philippe, I know there's another question from Falk, which I don't know if we directly addressed it already, right? But asking.
I think
behavior.
it's the same from Lorenzo.
Yeah, okay. That's
Okay.
what I thought. Okay. Well, folks, I think we will call that a wrap. I think this was a great webinar. First, I want to thank both Taylor and Jean-Philippe for your participation. This was great. I really hope it was useful and helpful to all the folks who joined. As I mentioned, please keep an eye out for the published recording. Will come out in a few days, and stay connected with more upcoming webinar events that we're going to be hosting. Okay, thanks everyone. Have a good day.
Thank you, everyone.
Thank you.